Hello, this is part two of the continuous chapter test derivatives. So yes, go ahead and we're going to test your knowledge on the different derivative techniques. So let's just continue on with question 10. So question 10 says we have y equals 2x minus 5 times x plus 1 over x plus 2. We got to find y prime. So we'll definitely have to use the quotient rule, but more specifically, before I do the quotient rule, could we simplify the numerator? Yes, we can. Um, if you FOIL this out, 2x, that would be 2x squared plus 2x minus 5x minus 5 all over x plus 2. And if you clean it up a bit more, so this is going to be 2x squared. 2x and negative 5x is negative 3x. 2x plus negative 5x negative 3x minus 5 all over x plus 2. Okay. Now you may use the quotient rule. So your f is the numerator, which is 2x squared minus 3x minus 5. And your g is the denominator, which is x plus 2. And then what's f prime? The derivative of 2x squared is 4x to the 1. The derivative of negative 3x is negative 3. The derivative of negative 5 is 0. And what is g prime? The derivative of x is 1. The derivative of 2 is 0. So if you recall, the quotient rule is f over g prime, which is f prime of g minus g prime of f all over g squared. Okay, so my y prime is going to be, my f is did I do this right? 5x minus 2x is negative 3x. Oh, my f prime is 4x minus 3. Sorry. Yeah, 4x minus 3 times my regular g, which is x plus 2. There you go. Minus, and I'm going to use a bracket because I have to distribute minus, and then g prime is 1. And then f is 2x squared minus 3x minus 5 all over g squared. So my g is x plus 2 squared. And then if you FOIL this out, 4x times x is 4x squared. 4x times 2 is 8x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Minus bracket 1 times this whole thing itself. All over the bottom. So before I do distribute this minus, clean this up a bit. So it's going to be 4x squared, 8x minus 3x is 5x, minus 6, and then distribute this minus, so it's going to be negative 2x squared, it's 3x plus 5, all over x plus 2 squared. And then I guess you can clean up the numerator. 4x squared and a negative 2x squared is 2x squared. 5x plus 3x is 6 and 8x. Negative 6 plus 5 is negative 1. All over x plus 2 squared. Final answer. And that is your final answer. Okay, let's move on to question 11. So we have y equals x minus 5 times x minus 1 times 4x plus 3x squared raised to the second power. So what technique should I use? Well, I definitely would use the product rule because you're multiplying two terms, but I don't see two terms. I see three terms. This is one term, and this is another, and this is another. So we got to make it two terms. So what I would do is break it into two parts, split this in half, FOIL this out, collect like terms, then that would be your F, and then your G would be this, right? So go ahead and FOIL this out. So this is going to be x squared, negative x, negative 5x, plus 5. And then you get x squared, negative 1x, and negative 5x, and negative 6x, plus 5. And then you may use a particle. So your F is this, G is this. So F is x squared minus 6x plus 5. G is and then F prime is the derivative of x squared is 2x. The derivative of negative 6x is negative 6. G prime is the derivative. So how do you take the derivative of this? You have to use the power rule and chain rule. So start with the power rule. 2 times this is 2. Leave the inner parentheses alone. And then old power minus 1, so 2 minus 1 is 1. Then you apply the chain rule. So you take the derivative of the inner parentheses, so 0 to 4x is 4. The derivative of 3x squared is 6x to the 1. And you can either leave it like this or you can clean it up. It's perfectly fine. So if we continue doing the product rule, it would be y prime is so f prime is 2x minus 6 times it by g, which is this whole thing, plus g prime is 2 times 4x plus 3x squared times by regular f, which is x squared minus 6x plus 5. So you can leave it like this, but more specific, is there anything you can factor anything out? I think we could factor out a 4x plus 3x squared. And I think we can only take out 1 because this has 2. This is 1. Yeah, we could take that out. And then if we do that, that means we have a 2x minus 6 times 4x plus 3x squared and then plus 2 times 4 plus 6x. Okay, so that can be your final answer. So that, yeah, that would be final answer. Pretty simple, right? Just product rule and cleaning things up. Okay, so let's move on to 12. We have f of x equals the cube root of x times square root of x plus 3x minus 1, and we must find f prime of x. So what would I do? Maybe I would rewrite this problem in terms of power only. So you could say f of x, and then the cube root of x is the same thing as x to the 1/3. And then square root of x is the same thing as x to the 1/2 plus 3x minus 1. Then you may FOIL this out. So what's x and 1/3 times x to the 1/2? Well, when you're multiplying, you're adding. So what's 1/3 plus 1/2? That's 5/6. So this is going to be x to the 5/6. And then what's x to the 1/3 times 3x to the 1? So it's going to be 3x, and then 1/3 plus 1, or 3/3, is 4/3. And then what's x to the 1/3 times -1? Negative x to the 1/3. And then take the derivative. So what's the derivative of x to the 5/6? It's, you just use the power rule. So this is going to be 5/6x, and then old power minus 1. So 5/6 minus 6/6. That's -1/6. Plus, what's the derivative of 3x to 3x raised to the 4th power rule again? So what's 3 times 4/3? That's 4x, and then old power minus 1. So that's 1/3. And then we'll derive this, use power rule. So this would be -1/3 x, and then old power minus 1. Now, if you want to rewrite this as a positive power, that's perfectly fine. So 5/6 of x to the -1/6 as a positive power would be the same thing as 5/6, and then x to the +1/6, right? And then this is positive, so you don't worry about that much. And then how do I write this as a positive power? So this is going to be -1/3x to the +2/3. And then you could actually do one more step. You can rewrite this as a square root, because it had a root in it. So yeah, that's perfectly fine. So this as a root would be 5/6, and then x to the 1/6 is the same thing as the 6th root of x. And then 4x to the 1/3 is the same thing as 4 cubed root of x. And then you have -1/3, and then x to the 2/3 is the same thing as the cube root of x squared. Okay, so that is your final answer. Okay, let's move on to 13. So we have y equals the square root of x squared plus x minus 1 over x squared minus 1. Okay, so this one is a little bit more more work. What we have to do is, to find y prime, you're going to have to use the power rule. And it looks like also chain rule. So yeah, let's do that. First, let's rewrite this as a power. So this is the same thing as y equals parentheses x squared plus x minus 1 over x squared minus 1 raised to the 1/2. Now you may use the power rule and chain rule. So it's going to be y prime. So first use power rule. So 1/2 times plus 1 is 1/2. Leave the inner parentheses alone. And then old power minus 1. So 1/2 minus 1, or 2 over 2, which is negative 1/2. And then you must use the chain rule. So you got to take the derivative of this. How do you take the derivative of that? Use the quotient rule, right? That's a pain. So let's see. What is the derivative of x squared plus x? Yes, you said it is the quotient rule. So what's your f, what's your g? So your f is the numerator. F prime is 2x plus 1. G prime is 2x. So when you do the work, it should give you 2x plus 1 times x squared minus 1 minus bracket 2x times x squared plus x minus 1 all over g squared. So let me clean this up because I already did this one. So the numerator, when you clean it up, it should give you, so when you FOIL it out, distribute this minus, etc., you should get negative 1x squared minus 1, and then on the bottom, it's still the same. Okay, so that is the derivative of this. So you could say times the derivative of that, which is negative 1x squared minus 1 over x squared minus 1 squared. So, wait, what do we have now? So this is what we have. We have 1/2 of x squared minus 1 over x squared plus x minus 1 raised to the 1/2 of negative 1x squared minus 1 over x squared minus 1 squared. And what could we do? We can rewrite that power of 1/2 as a square root. So you could say y prime equals 1/2. So this could be written as a square root as the square root of x squared minus 1 over x squared plus x minus 1 times this whole thing. That would be your final answer. Okay, let's move on. Let's move on to 14. So let's say we have y equals x squared over e to the x. So you can either, so on this option, you can use quotient rule or product rule. So how can you make it as a product rule? Well, I'm going to use the product rule because I don't like the quotient rule. So I can rewrite this problem using a negative power, so I'm going to leave x squared alone. But how would I rewrite 1 over e to the x as a negative power? Yes, it would be e to the negative x. So I'm going to use the particle and I'm going to figure out my f and my g. So my f is x squared. My g is e to the negative x. And then my f prime is 2x. And then my g prime, the derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1. So that would be simplified as negative e to the negative x. Okay. Oh, the direction says to find dy dx. So we're doing a little bit of implicit differentiation. The good news on the right side, there's no y, so we don't have to worry about the you don't have to worry about the variables. But on the left, what's the derivative of 1y in respect to x? Yes, it would be dy dx. Now continue on with the particle. So the particle was f prime of g plus g prime of f. So f prime is 2x. G is e to the negative x plus g prime, which is negative e to the negative x times regular f, which is x squared. E to the negative x can be written as 1 over e to the x, and then you have 2x here, plus the same thing here. You have a minus, and then e to the negative x is 1 over e to the x times x squared. So this is going to be dy dx, and then you get 2x over e to the x, and then you have minus x squared over e to the x. Now you're subtracting fractions, so the good news is they both have an ex on the bottom. So your final answer will be dy dx equals 2x minus x squared over e to the x. Or you can factor out an x on the top, so this would be x times 2 minus x over e to the x. So you could use this as my final answer, or you could use this. Okay, let's move on to 15. Okay, on 15 we have y equals 5x raised to the 20 minus cosh of square root of x. So we got to find the y prime. So we have two terms. We don't have to use the product rule. We just take the derivative of each term. So how do you take the derivative of 5x to the 20th? You use power rule. So power rule, 20 times 5 is 100 x, and then old power minus 1, so 20 minus 1 is 19. Then what is the derivative of negative cosh of square root of x? Well, the derivative of cosh is sinh, but there's a minus, so it's negative sinh square root of x, and then you have to take the derivative of the chain rule, right? You got to take the derivative of square root of x. So what's the derivative of square root of x? 1 over 2 square root of x. And when you put it all together, you get y prime equals 100x to the 19th minus let's move on. Okay, 17, we have y equals ln of x squared minus x over x minus 2, and we must find dy dx. So we have an ln. So if you recall, we're going to take the derivative using ln. So on the left, wait, so if you recall, the derivative ln of x is 1 over x times x prime, right? Same concept for this one. It's just that our x is not x, is this whole thing, which makes it a bit more difficult. But let's start with the left side because we're doing implicit. The derivative y in respect to x is 1 dy dx. On the right side, everything is in terms of x, so we don't have to worry about putting a dy or dx anywhere. So it's going to be 1 over x squared minus x over x minus 2 times the derivative of the inner parentheses. Okay, so what's the derivative of this? Unfortunately, you're going to have to use the quotient rule. So x squared minus x over x minus 2, that is going to give you, so if you apply the quotient rule, it would be so when you clean that up, that should give you, does that give you? So on the numerator, it should give you x squared minus 4x plus 2. And then on the bottom, it's x minus 2 squared, right? So if you FOIL this out, distribute the minus, etc., it gives you that. So what we have is dy over dx. And then how do I simplify this? It's a complex fraction. So you can rewrite this as 1 divided by, and then you may cross multiply. So this would be x minus 2 over x squared minus x, right? So this part right here simplifies as x minus 2 over x squared minus x times the derivative of this, which we did the work, or I did the work, simplifies as x squared minus 4x plus 2 over x minus 2 squared. Okay. Do you see anything that cancels? Yes, I do. I see this x minus 2. This has a power of 1, so when you're dividing with the same base, you subtract, so this cancels, and now you're left with the power of 1. So your final answer will be dy dx equals to x squared minus 4x plus 2 over x squared minus x times x minus 2. Okay, so that is our final answer. Okay, let's move on to 18. So we have, in 18, we have f theta equals theta times tan inverse of 3 theta. And the direction says find f prime of theta. So what technique shall we use? Yes, we should use the product rule. Now, keep in mind, theta is not a constant, so do not factor out theta and distribute it. And then bring it down. Instead, you could think of theta as like x. So x is a letter, so you must use particle. So what's our f? yeah, my f is this, and my g is this. So f is theta, and then f prime is 1, and g is tanh inverse of 3 theta. G prime is what? Uh, what is the derivative of tan inverse? It is 1 over 1 minus x squared. So your x is like your 3 theta. So it's going to be minus 3 theta squared times the derivative of x prime. So the derivative of x prime is 3. So g prime is going to be 3 over 1 minus 3 theta squared is 9 theta squared. Okay, so now you must use, now you may continue with the particle. The particle is f prime of g plus g prime of f. So my f prime is 1, my g is 10 tenth plus g prime, which is 3 over 1 minus 9 theta squared times it by f, which is theta. So you can rearrange this if you want. You could put, you can leave it like this, or yeah, you could put this in front. It would be 3 theta over 1 minus 9 theta squared plus tan inverse of 3 theta. So that's your final answer. Okay, so we did 19. Let's move on. Oh, no, that was 18, right? Yes. So let's move on to 19. So on 19, we have y times ln of x equals negative y squared, and we must find dy dx. So we got to be careful because we're doing implicit differentiation. So we got to yeah, we gotta do the left, we gotta do the right, and we're taking it in respect to x. So let's start with the left side. We have y times ln of x. So how do you take the derivative? Product rule, right? So this is your f, and then this is your g. So if my f is y, my f prime, the derivative of y is 1, but be careful, we're taking it in respect to x, so you do have to add this dy dx. And then my g is ln of x. So my g prime, the derivative of ln of x is 1 over x times the derivative of x, which is 1. And then you do have the option of putting, because we're taking it in respect to x, dx over dx, but what happens? That becomes 1, so that's not really necessary. And then you just apply the product rule. So, okay, f prime is 1 dy dx. My g is ln of x plus g prime, which is 1 over x. And then f is y. There. So 1 dy dx, blah, blah, that's like ln of x times dy dx plus what's 1 over x times y? It's like y over x equals, and then now do the right side. What's the derivative of this in respect to x? It would be negative 2y, and then you do have to add that dy dx. Is this our final answer? No, not quite, because we got to put it, our final answer will be in dy dx, so we kind of have to move things around. So I could recommend anything that has a dy dx, get on one side, anything that doesn't, leave it as it is. So this has a dy dx, so how do I, no, actually, let's move this to the left and then move this to the right. So I'm going to add 2y dy dx. And then I'm going to subtract this negative y over x, right? So you have ln of x dy dx equals to negative y over x. Okay, so that's much better. Now on the left side, we have a dy dx. So you want to factor that out. This is ln of x plus 2y. And then on the right, it's negative y over x. And then solve for dy dx by dividing both sides by ln of x is 2y. So this cancels. So you have dy dx equals to negative y over x over ln of x plus 2y. We have a complex fraction, so this is your numerator. This is my denominator. This has a denominator of 1. This has a denominator x. So I'm going to do the bracket method. And I'm going to multiply, what's the LCD between 1 and x? X. I'm going to multiply both top numerator and denominator by x. So this would be negative y. And then when I multiply here by x, it's going to be x times ln of x plus 2y. And that is your final answer. Let's do one more and then we'll stop here. Okay, so 20 says, what is the limit? I know we're dealing, this is related to derivatives. What is the limit as x approaches 2 of f of x minus f of 2 all over x minus 2? And f of x is equal to x minus 1 raised to the 2/3. So what are they really saying? So it's really saying find f prime of 2. So yeah, that's what they're really saying. If we know that our f of x is x minus 1 to the 2/3, let's find f prime of x. Not too bad, right? You just use power rule and chain rule. To start with the power rule, this has a denominator 1, so 1 times 2/3 is 2/3. And then you have x minus 1, and then old power minus 1. So 2/3 minus 1, or 3 over 3. That is negative 1/3 times the derivative of x minus 1, which is 1. You have, let's rewrite this as a positive power, so this would be 2 over 3 of x minus 1 to the positive 1/3. And you can rewrite this as a cube root. So this is 2/3, and then you got the cube root of x minus 1. And then you may apply the x value too. So 2 minus 1 is 1. This is 3. And then what is the cube root of 1? 1. So that is 2/3. So f prime of 2 is 2/3. That's what they want. So that is your final answer. Okay, we will stop here.